Hi, I'm Angela Rasmussen from the University of Utah Electrical and Computer Engineering Department, and I wanted to talk today about what is a current source. So a current source has the symbol that is a circle, and then you can define the direction of the current. So this would be a current source. The direction is going to follow conventional current flow, so this would be a plus to the minus, always the arrow side. And it's going to have some value, fixed value of I. That's going to determine how much current is flowing in the branch that this current source is located. Across from that, you're going to have an unknown voltage Vx. And that Vx is going to be determined by the external circuitry that is connected to it. So, backing up slightly, every element, I'm going to just draw an element as a box. Every element has across it a current and a voltage. Typically for a positive, so this is a resistor in there. So if you had a resistor in there, this would be I times R would be your voltage. So if it's not a resistor in there and it is some other element, then you are going to be able to always have still that voltage and current. So that is a concept that you need to memorize, that every element will always have a voltage and a current that goes through it. So back to the current source is that you have a fixed current, then you're going to have a variable voltage. So what we can also visualize this as is called an IV curve. And on an IV curve for a current source, your I is on the x-axis and your V is on your y-axis. What this shows is that as I have a fixed current, I can vary anywhere on here with the voltage value. For a voltage source, on the other hand, the polarity is fixed by the plus and the minus directions. Your voltage is going to be the fixed value, and then your current is what can vary on here. If you look at this in contrast, you're going to have your IV, still your IV curves, and then you're going to have a fixed voltage and your currents are going to vary. So say this is 10 volts, or you could have a 5-volt battery, and either one of those you're going to have a vertical fixed voltage, and then your currents vary depending on the external sources. So I wanted to kind of visualize what goes on here. So this is a 1 milliamp that's fixed in one branch, and then you have the voltage is determined by the resistance that's located here. So if I change this resistance to a large value, you're going to see that your voltage is going to be huge. So at first it was a 1K, so you had a lower value, and then if I go really small, you're going to have, so go to about 2 ohms, and then you're going to have a small voltage that is there. So a small voltage results because the resistor has changed to a small value, and this makes sense because we have I times R. So we have the voltage is I times R, so if we decrease R, then our voltage is going to decrease. If we increase R, our voltage is going to increase. In contrast to this, if we have a voltage source, the voltage stays fixed, the current changes. So here you have about an 8.7 K resistor, and you have 115 microamps. As I change the resistance here, so I get really big, you're going to have even smaller you're going to go into the nanoamps of the current. So the voltage still stays fixed, but the current changes. And then if I go really small, so six ohms, then you're going to have a lot larger of a current, 161 milliamps. So again, V equals IR. If you change the resistance and keep the voltage fixed, then you're going to be looking at this as the current changing is going to be V divided by R. So with V fixed, R changing, if you increase R, then you're going to decrease the current where we saw it went really small, and when we increase or decrease R, we get a higher current. So this matches Ohm's law also. So in summary, a current source, you're always going to have, every element is going to have a current and a voltage across it. And then as you have a current source in there, it fixes the current in a branch, and the voltage can change. And okay, so if you have a constant voltage source, you're going to have a change in the current changes. So constant voltage source, you're going to have current can change. And if you have a constant current, you're going to have the voltage can change. All right, thank you for watching. Hopefully this has helped you understand current sources a little bit better.